In this unit, we're going to continue our study with trigonometry, but we're going to be looking at something called radians. Now, just like you can do measurements in inches or centimeters, angles can be measured in different units. We've been using degrees for a while now, but there's also something called a radian. Now, radian measure is based on what is called the unit circle in trigonometry. And the definition of a unit circle is that, it's a circle with a radius, that should be with a radius of 1. So think about a circle with a radius of 1. It's the simplest circle we could come up with. Now, if we were trying to find the circumference of that unit circle, circumference equals 2 pi r. And if the radius is 1, that would mean the circumference equals 2 pi. So let's think what we would multiply 360 degrees by to obtain that circumference. So 360 degrees times what would equal 2 pi? Well, let's think about that. 360x equals 2 pi. If I divided both sides by 360, I would get x equals pi over 180. This is called the conversion factor. This is how we would convert from degrees to radians. Now, the thing I want to make sure we remember is 360 degrees all the way around the circle would be the same as our circumference of 2 pi all the way around the circle. So to convert from degrees into radians, what we would do is take the degree times pi over 180 degrees. Now the degrees would kind of cancel out and we'd be left with radians. If we had radians and we wanted to convert to degrees, we would multiply by the reciprocal 180 degrees divided by pi. The pi and the radian would cancel out and we'd be given our degrees. So that's the first objective for us, is to convert to the other unit. So if we're given degrees, we're going to multiply by pi over 180. And so that would be 90 pi divided by 180. And that would be pi over 2. Negative 235 degrees times pi over 180 degrees. Negative 235 pi over 180. Now, to simplify this, which I would do, you do not have to put the pi in the calculator. And I would advise not. You can, but you don't have to. So if you had another older calculator, you could just do the 235 divided by 180. But mine will leave it with the pi in it. So, I forgot the negative sign, so I need to make sure this is still negative. Now we've got a radian. Now, I know the difference between a radian and a degree because the degree would have the degree symbol, and the radian usually has a pi in it because radians deal with the circumference, which would be 2 pi. So 2 pi over 3. If I'm transferring to degrees, I want the degrees on top, and I want to cancel out the pi's. So if I do that, the pi's would cancel, and I'd have 2 times 180 degrees divided by 3, which would be 120 degrees. Negative 13 pi over 6. I want to cancel out the pi's, so I'm going to put the 180 degrees on top, divided by the pi. And that ends up giving me, if I do 13, negative 13 times 180 divided by 6, gives me negative 390 degrees. So that's our first objective, is converting from one unit to another. The next objective is coterminal angles. Now, let's remember how we did coterminal angles with degrees. We added 360 and subtracted 360. So I'm going to do this first by converting to degrees. So I'm going to take negative 4 pi over 3 and convert to degrees. And that would end up giving me negative 240. And the reason I did that really fast is I did 3 into 180 is 60, and 60 times 4 is 240. So if I can convert to degrees, then I would add 360 and get my positive angle. That would have been going around the circle one more time. And then the other one is subtracting the 360. That would be going around backwards. So that would be negative 600 degrees. But those would be my two coterminal angles. So let's think about that. Negative 240 would be backwards past 180 up in this quadrant, and it'd be about 60 degrees into that. So positive 120 would be going this direction, 120. Negative 600 would be going around backwards a whole 360 and then 240 more, and would end up in the same spot. Now we can do this without converting to degrees, and it goes a little bit faster. All we're going to do is add 2 pi, because 360 and 2 pi are the same, and subtract 2 pi. So if I take negative 4 pi over 3, and I add 2 pi, and then I'm going to take negative 4 pi over 3, and subtract 2 pi. Now at first you go, oh gosh, I hate doing fractions and stuff. Well, I just want them to have the same denominator. So 3 is on the denominator, so I want this to have a denominator 3. So the version of 2 pi that has a denominator 3 would be 6 pi over 3. I just multiply the top and bottom by 3. Think of that as 2 pi over 1. And then I just add. Subtracting, I already know how to convert 2 pi, so that'd be negative 6 pi over 3, negative 10 pi over 3. I find that's actually faster. So let's practice. First, let's look and see if we can figure out what quadrant we're in, what's our reference angle, and then find our positive and negative coterminals. So 13 pi over 6. Let's think where that would go. 13 pi over 6. Well, all the way around is 2 pi. So halfway would be 1 pi. Well, 13 pi over 6, 13 divided by 6 goes 2 full times, because 12. 6 goes into 13 2 full times with a 1/6 left over. So 2 pi with a 1/6 left over. So this little extra would be 1 pi over 6 left over. So my reference angle is pi over 6. And it landed in quadrant 1. And if I wanted to find a positive and a negative coterminal angle, well, first off, I know that pi over 6 is a positive coterminal angle. So one of them is pi over 6. And if I subtracted 2 pi from that, minus 2 pi, which I'm going to change to 12 pi over 6, I would get a negative 11 pi over 6. And by the way, if you have trouble with the fractions, pi over 6 minus 2 pi, the calculator can do it for you. Negative 3 pi over 5. Okay, so is that going a full pi? No. It's short of being a full pi. So pi would be here, but I'm short from that. A full pi would be 5 over 5. So I'm negative, so that went that way, so 3/5, so 2/5 is left. So my reference angle would be 2 pi over 5. And I'm in quadrant 3. And if I got my two angles, I would be adding 2 pi and subtracting 2 pi. So negative 3 pi over 5 plus 2 pi. That gives me 7 pi over 5. Then if I subtract 2 pi, which by the way, I said you could do this in the calculator too, I get negative 13 pi over 5. You want a positive and a negative. 11 over 2. Ooh, okay. So let's think how far that would go. Okay, so 1 pi, 2 pi. How far is this going? 2 into 11. 2 goes into 11 5 full times. So if I was doing 11 divided by 12, I'd have 5 full times and a half. Okay, so 1, 2, 3, 4, 5 and a half. So this one didn't land in a quadrant. It landed on that y-axis. So as far as a reference angle, my reference angle would be just half of a pi. My reference angle would be pi over 2. Quadrant is on the y-axis. And a reference angle, well, let's see. If I did this in the calculator, I could take 11 pi over 2, and I'm going to subtract 2 pi. Well, that gave me another positive angle. I want a negative one. So I'm going to take that last answer minus 2 pi. Oh, I got another positive. Answer minus 2 pi. There's a negative. Oh, and that makes sense, going backwards half of a pi. Last one. Negative 7 pi over 6. So 7 divided by 6 would be 1 and a sixth more. So I'm going a whole pi and a sixth more. Right there. So quadrant 2. Pi over 6 would be my reference angle. And then I would add 2 pi and subtract 2 pi. And subtract 2 pi. Now I challenge you to do some of these practice problems before you do your mastery check. I'm going to have the key posted